All right, looks like we're recording and ready to go for today. Before we begin going through normal agenda topics in terms of work going on in the project and what's been completed recently, does anyone have any topics they would like to talk about today? Or just any questions about the project, technical or direction or anything like that? All right. If not, then I will go ahead and proceed. Generally, as we go through some of the work that's been done, or we talk about things that we are working on as kind of longer term initiatives that kind of spur some discussion in a few different areas. So I will begin doing that again. I apologize for this not having the titles like before. I will fix that after the meeting. But for now, I'll just go through these one by one so we can talk about them. To begin, this is the link here where the community calls are posted. So this video will be posted there after the meeting. Active RFCs that we have is just this one for 1474 at the moment. This one's been open for a while, so we won't spend much time talking about it. It's been open since April and hasn't had much activity. The other RFCs that were open since the last meeting have all been merged. So we did a pretty good job closing out those and making progress on the RFC direction. Active work items, we have three main changes that are currently up in the repository right now. Whenever we kind of go into like larger project trends, we can talk about some of the work we are doing in the SDK crate that we provide. But this PR here is tied to doing some more cleanup related to the SDK changes that we are making in the crate. Just so people are aware, we have three main branch types that we use in Patina. One is the main branch. That is the one where we strive to do all development. And I would say like probably 95% of our development happens on main directly. We have another branch type that can be created called feature, and you will see that one here. So, one of the long-term initiatives I've spoken about in the past is the fact that we are writing an MM supervisor in Rust and Patina. So you will find a feature/SUPV branch. That is where that feature code is kept. The idea being that anything that is on the main branch, we consider to be ready for production integration into platforms and systems. Things that are not ready go into feature branches. So that's what you see there. I think right now this is the only real active feature branch we have. It's not like we have tons of feature branches spread all over the place. We just have this one branch here that I'm aware of for the supervisor at the moment. And then the other branch type is the major branch. What we use the major branch for is whenever we accumulate changes where we're making breaking changes, we try to balance decreasing technical debt, which is like, okay, we like any programming project in order to be more efficient, in order to continue this project in a direction that is clean and has the interfaces we want and gets rid of all the cruft, we're going to have to get rid of some things from time to time that are going to be breaking changes. Those go into the major branch and we accumulate those. This is all described in documentation on the MD book, but we accumulate those changes into the major branch. And then whenever we reach a point that all the changes in the major branch are ready to be released, we merge those into main, and then we do a breaking change from the Patina main branch. And so you'll see that reflected in the semantic version of Patina that comes out. So for example, right now in Patina, we are on version 22.2.3. Whenever we take all the stuff in the major branch that's there right now, we will have version 23.0.0, right? And so that's how we kind of manage keeping main at being able to release stuff on a regular cadence. People can get bug fixes, people can get all of our normal changes that are not breaking, and then we kind of just do bigger breaking changes where probably several things have accumulated together, and that justifies moving the major version on the semantic version there. So just a heads up for people about that process and how that ties into these PRs that are targeting these different branches. So again, this one's breaking change, and that's why you see it going into major. We have other changes in major at the moment that this is kind of adding on to there. This one here is targeting the supervisor branch. It's just a code update change. We won't spend much time on for SMRR and SMM code access changes. And one change from John here is he's adding build time construction support for device paths. This one here, like he says, is more of an ergonomic change, and I think it's pretty nice in terms of what it allows you to do. But it allows you to be able to specify a device path like this, which looks pretty natural, and you can have that converted into its byte sequence or byte array to use in code. Doesn't look like John is here. I'd let him talk a bit more about it, but that's an ergonomic improvement to just make it so you can naturally specify device paths and get back the byte array that you'd like. Okay, that covers the active work items. Going through notably closed items is going to be tough with the numbers, but we'll do it. On.
Hey Michael, I have a question about that major. So at what point major will, I guess, merge into main and be the one that you can release on the Grace IO?
It essentially comes down to the maintainers of the repo will talk to the contributors in the major branch and figure out when all the changes are final and ready. So it's kind of intentionally meant to be a process that has some flexibility in it. Um, so there is not an exact time, but I think it's obvious to probably the people involved in the changes in the major branch when those will be ready to go to main. Another thing to note is that the major branch does not necessarily go into main the exact same way that the changes went into the major branch. We kind of use that as an opportunity to also say, okay, all of these breaking changes happened. They happened in an order that made sense based on implementation and maybe on other factors. But whenever we're taking those into main, we may want to consolidate some changes into different commits. We may want to reorder the commits because the ultimate project goal is to have main be as clean, clear, and stable as possible. And so in order to achieve that, we may refactor things coming in from the major branch to main because we don't care about the major branch. It's disposable, right? But we do care about the way things are reflected in the main branch. Oliver?
Yeah, just noting, as Michael said, there's a section in the MD book on this, and there is a process, if a platform's on, V22, right, and V23 is already released and some bug fix or security fix is needed to, be able to file and say, hey, can we make a release based on, this older tech, etc.
Yeah.
So
So
is
just
this more like the on-demand, or do you have a cadence like Rust compiler every, I guess, 3 years? You have a cadence of that, then you stuff everything into that release,
let
or
me
it's
just
still like
I'll explain really quick because it's not that complicated. I'm just going to go directly to the RFC. So if you go to docs and you go to RF source and you go to RFC and you go to text and you search for release process, this will have all of our RFCs, and this is under the release process RFC. And so if you go in here and you search for the major branch, this is so number one, I'm going to put it in chat. This is the RFC that you should look at if you're interested in how we do releases, whether it's from main branch, major branch, or wherever, right? This is where all of that's consolidated. But just to directly answer the question about release cadence, we release weekly, and from the main branch. So if I go back to the main repo, we will see that we just did a release this week 1 hour ago. And if I go to releases and I went and look at when the last release was, I will see that it was last week, almost 7 days ago, right? So we're at like 8 days off. And so we do these normal releases from Maine on a weekly cadence. We normally will do it on Tuesday or Wednesday. And that is, like I said, the whole point of the major branch is that we can do this from Maine uninterrupted, right? Like there are no breaking changes in this main branch right now, but we have several breaking changes over in the major branch. The reason why we were able to make this release an hour ago is because we don't have the breaking changes in the main branch. So that's the normal cadence. For most intent and purpose in working in the project, all you need to really know is that we do a release from the main branch on a weekly basis. If you are particularly interested in what's going on in the major branch at any given time, and sometimes we have nothing in the major branch, right? It's not like there's chaos in the major branch always going on. Sometimes, most of the time, the major branch is just empty. It doesn't have anything. But if you are interested in what's going on in the major branch, you can go look. And then the process would be, as it says over here, we talk about whenever we merge major back into main and all that kind of stuff. Like I said earlier, we accumulate breaking changes. We merge that into main. We try to go for about monthly or as needed. So I personally have a timer that I set where, and after a month, I will go ask the contributors to the major branch, are we ready to go to main? And if we're at the point that we can, we do. If there's more work needed, that happens. But the ultimate goal is to not sit in a major branch very long and to keep main stable. So we kind of have some flexibility built in to allow that to happen.
Thank
Does
you.
that make sense? Okay. All right. That does mean, though, that our real goal here is that if you're a consumer of Patina, you should be able to take patch updates, and those are going to be fairly safe, right? Or they will be safe. Like unless if you get broken by a patch update, we obviously mess something up. But that's the reason why we have this process. It's so that we can make breaking changes on a fairly regular basis, but they don't necessarily get released and impact consumers on a regular basis. That's more infrequent, and that's done through those releases. Um, all right, going back down to this, I'm just going to go ahead and pop some of these up. So, fortunately, this exists. This one here on 1658 is we had a feature called doc. We replaced with doc config. The doc config is set by Rust doc whenever it runs, and we didn't need to have a separate feature for it, so we got rid of that. It's general code cleanup. This one here was a larger change that I just merged yesterday, and in it, I was adding this is pretty directed toward you because you've been asking about string types. This provides native, safe, idiomatic Rust string types for UEFI strings in the Patina SDK. So if we break down the two main string types defined in the UEFI specification, we have char 8, 1 byte character, specified as a fixed 8-bit width. We have char 16, fixed 2 byte character, UCS2 encoding, and defined by the standards and everything like that. So these types are added to support complete compliance with the UEFI specification whenever that's required. And so there are 3 different types added that you can use, much like how there's str and string in Rust. There is str and string variants of these. And then there is a owned fixed capacity version that is used in things like binary structures and stuff like that to be able to have a string. These, as I said in the MD book documentation for this, which you can find if you go over to here and you go to UEFI strings, there is a page in here that talks about these in detail. And if you need to know when to use which type, you can go to the choosing a type section and see which type to choose. And there's also some examples in here of common use cases like using a string from the FFI, having compile time string literals and how that is done, and how you would put a string into a binary structure and use that, and how you would use this with zero copy. If you are, let's say you have a struct like this one that implements zero copy traits, you can use the string types with that. It also goes into other examples of creating strings with null characters from byte sequences and those types of things. So these are kind of crafted in such a way that they align with our philosophies on panicking, they align with our philosophies on error handling, and they, for the most part, are as close in interfaces as possible to the C string types in the Rust FFI library. So if you're familiar with other Rust string types, these should be, the interfaces here should be pretty familiar to you. That being said, you don't have to use these everywhere. So these are meant to be used in places where, like that document that I just showed says they should be used. And it's mostly whenever you're working with UEFI, with interfaces or code that has UEFI spec expectations. If you are just using strings in general in the Rust code, you can just use the normal Rust string types. This does not replace the Rust string types. It uh, only allows you to have a safe idiomatic type to use when you're working with UEFI string types. So just don't overuse them, because if, unless you are aware of, like, let's say you're using set variable, right? Set variable requires, as we know, a char 16 buffer of code units for the variable name. If you're working with that interface, because that's a UEFI spec interface that requires the char 16 type, you should use the char 16 type. If you are just creating a string and you're using it in a unit test to test like string equality and it has nothing to do with the UEFI spec, then do not use the UEFI string types. So you just have to use these whenever they're relevant in the code. All right, so that is 1657 was adding those string types. 1654 was a change to the memory protection policy to default system memory to write back. I don't think, Oliver, is there anything else you want to add for context around that one?
No, this is something that we wanted to clean up versus EDK2, particularly for x86 systems that often will show they have 0, which is a meaningless type. But in reality, the system memory was being write back because of MTRRs. This was just a way to have it be cleaner. And there's a couple of cases where we need to fall back to a default. And so this is doing that, but no functional change, hopefully.
Right. 1648 was a change I made. I guess at a high level, I should talk about this really quick. Since our last meeting, we did switch over. We talked about, I believe, the RFC to switch to the stable toolchain in the last meeting. That got implemented, and some of these changes are related to that. I believe down here toward the bottom, this first one is the RFC 1592. And if we go to that, I believe you'll see a link in here. Maybe not. So this was the RFC to move to stable Rust with Rust C bootstrap equals 1. We made that change. What also was made was a change to limit the allowed features to only the features that we use. And so if you go to our config.toml file and you look at the allow features list, you'll just see 2 features. We allow cvariatic and allocator API. Those are the only 2 unstable features we use. And because of feature enforcement, those are probably the only unstable features used in our entire crate stack, because otherwise we wouldn't be able to build. So we have tracking GitHub issues for these, as we've mentioned before, but we limited it down just to these. Now, one other feature that we do use is the coverage attribute feature. And the coverage attribute feature allows us to be able to put, to be able to mark certain sections of code or functions as not being covered for code coverage. So like if there's something that, let's say, is just going to go interact with an MSR or some hardware interface on a system, we do not want to do that in a real unit test, right? Like we don't want someone to run a unit test, which gets compiled as a host application, and then start screwing around with MSRs on their computer and stuff. It'll just get us into an exception. So what we do in that case is we'll mark the code no coverage, which means we're not going to write a test for this code. It doesn't make sense to write a test for this code. The coverage attribute allows us to do that. And the way that we only enable the coverage attribute feature whenever we're running coverage is in the make file. There's a coverage task in here. And in that coverage task, we will set the, I'm just going to do this. There we go. All right. So in this task, which ultimately gets called by coverage, we will set the coverage attribute feature. So what we've tried to do is allow people to use the stable toolchain, which is great because now you don't have to worry about the nightly toolchain, which was a big complaint. And secondly, we've constrained the features allowed when using the stable toolchain down to only the two that we specifically allow. And whenever you run code coverage, we will basically inject that we allow that additional unstable feature when you run coverage. So we've minimized our unstable surface basically down to the bare minimum at the moment. At least within reason of what we want to use as unstable features. Okay, so that was what that kind of thing led to, and what coverage nightly to coverage was whenever this was done, cargo LLVM cov, much like how REST set the doc CFG, cargo LLVM cov will set a coverage or a coverage nightly CFG depending on which toolchain you are using. Because we were using nightly before, it was setting coverage nightly, and because we're using stable now, it's setting coverage, and so this change is accommodating that. Going to the SDK refactor, this is something that Chris Chris is not on the call, but Chris Fernald and the team is working on. I won't go super deep into this because there's a lot happening, and I think it'll be more appropriate to talk about it whenever it comes back into the main branch, because we may change things a little in the major branch, like I said before. But at a high level, if you're interested in what's happening in this larger refactor of our SDK crate, this is the PR to probably look at to get the best picture of what's going on. So it's 1646. This one in here, it's kind of talking about the new structure that we're using inside our crate. And this is something that we knew would evolve over time. It's like we're trying to define a way to best organize a bunch of UEFI firmware code and helpers and so on and definitions. We knew we weren't going to get it the way we wanted the first time. Like we may even do this again another time, right? This goes back to we would rather things reflect the way that we, based on current usage, based on what we've learned, we'd rather things be accurate, and we'd rather them be clean and instill best practices and stuff like that than be afraid to refactor. So this is a refactor of the SDK here. And the top level main modules break down to these if you're interested in like the high level organization and what's going on. But I think in the next meeting, like next month, this should be merged. And at that time, we can go into more detail about what changed and why. If you would like to get involved before then, obviously come comment on the PRs and stuff. But I think in terms of like looking at how everything's settled, we'll hold that for next time in more detail. All right, so this next one here was removing a debug function that was already deprecated before, and we said we were going to remove it, so now we're actually removing it. This here is about applying test guards consistently throughout the code. One thing, whenever I talk about these, I try to extract like common themes or maybe helpful advice or give an idea of like where we're going at a high level, probably the thing to extract from this change is that we have almost 90% test coverage. So we're doing better than we anticipated in terms of covering our code with unit test, which is great because we are aiming for 80%. Um, with that comes the fact that once you have so many tests, you now have to reconcile with the fact that you have to actually run all those tests frequently. And Rust will do that in parallel, which is very helpful. But we have some globals, and we have to synchronize access to those globals, and some of those are used in tests. That's not great, and we are going to try to minimize this global pattern that we're doing, but it exists today, and we have made improvements here, but we need to do a little bit more. Point is, whenever the tests are accessing some of these globals, like the GCD and the protocol database and that kind of stuff, because they're running in parallel, we have to synchronize access and we have to run those sequentially in some cases and stuff like that. We have a area of the code called test support that has some functionality to allow that to happen. And what I was doing here was kind of adding a new interface to make it simpler to be able to guard certain globals that are being accessed in test a little more ergonomically and reliably than what we are doing today. So my main point, I guess, with this change is that if you're writing unit tests, go look at test support and what exists there and decide if you need to serialize your test and what resources you need to write guards for if you're accessing them in your test. And this is basic stuff like if you use the GCD in your test and you manipulate it, we need to reset the GCD before another test uses it. Right? It's that kind. That's what the guards are used for. Okay. Moving on. There was a series of changes that were made to talk about or to address some security related findings. These were things that wouldn't be reproduced on a implementation. So we went ahead and fixed those in the main code. If you go through these items here, and I'll just keep them going, these are all kind of related to that general direction. So this first one here was a panic that got removed in the code. Second one was device path validation and a small change there in order to prevent a malformed device path from being accepted. Next one was whenever you're going, so the firmware file system is inherently a hierarchical kind of nested system, so recursion applies naturally. And the recursion was not bounded previously, so I added a bound inside the recursion going through there to 16 levels, which is more than sufficient for real world use cases, just so we have a bound. Next one was in some CRC 32 section extractor code. There was some validation that could be improved there when parsing a GUID. So that was done. And hob parsing is a common area where things come up in terms of validating incoming hobs are not malformed. This one here was adjusting the validation done for a GUID hob header. And this one here, whenever we do slicing, if you overflow, you can reverse the range slicing. And this one here is preventing, or underflow. This one here is preventing an underflow to prevent reverse range slicing. Just so people know, we do run a pretty comprehensive set of security suites against the code on a regular basis. And I think we probably identify and fix those issues faster than a lot of other projects. So that is related to that kind of series of changes there. All right, continuing on past those, we had a change to improve interior or to improve the serial implementation and how we do synchronization There, I don't know, Chris isn't here, so I won't go into this one in detail, but people can take a look if you're interested in the serial IO, or in the serial interface and what happened there. All right. Oliver, on any of the ARM exception stuff, is there anything you want to talk about?
No, just the high level was that there were a couple of places that weren't supporting EL1, and I added the support there. Typically, you see that in a VM case.
Yep. This is a change here to refactor the performance code. Performance is one of the Patina components we have, and that was refactored to better integrate it with the Dixie core. And this is going into the major branch. So this is one of the other changes in the major branch at the moment, is this refactor here. We have a simple assembly fix here for sign extension. This one is related to the coverage attribute stuff I talked about earlier. This one is another one to basically just put a sanity check on decompression size bounds. So whenever we were decompressing previously, we would allow, we didn't really bound the size of the memory used for decompression. So if someone said they had a super huge file and we went to decompress it, we would technically allocate that much memory. And this one here is putting a bound on that. We use a number of tools inside the project that come into our Rust toolchain file. And so I'll show what that looks like, because this is one people working in the project might need to know about. If you go to the Rust toolchain.toml file, there's this section in here that's called the tools section. And these are tools that are used in different parts of the build and CI process. We have like cargo deny, cargo Geiger, LLVM cov make, and so on, right? Like lots of tools to help with different things that are part of our just general build and CI. As you can see, we specify certain versions of those tools to use here. And we do that because we've tested compatibility with those versions. In some case, like the MD book ones, they're dependent on each other. So you may have an MD book release that comes out that is newer than what we're using, but we might not use it because there's a dependency that doesn't work with that version, right? And some of these things are not always versioned super well. So the point is, these are the tools we use, and these are the versions you want when you're working in Patina. Before we had like in CI a way that it would parse this section and install these tools on an agent. What this change adds is a task that you can run locally. So you can say cargo make install tools. And if you do, like this command here, if you do, then it will go parse that section and it will install the tools for you. So it will go verify that if you do have the tools installed, they're on the right version. Like this says here, I uninstalled Cargo Vet and then I put Cargo MD Book on an incorrect version, and you can see it installed Cargo Vet and it updated the MD Book to the version that's needed. So if you are working in the project and for some reason you're trying to do like an MD Book serve, so you can look at the MD Book locally and it doesn't work, you might need to just run cargo make install tools so you get on the right version. This one's the Rusty Bootstrap change, and we did change our LZMA dependency to a different crate. So we were using a crate called what was it called? LZMA RS before, and that one was not. It hadn't been updated in like 2 years, and we found the performance was not very good. Normally, in like a lot of platforms, decompression will happen prior to the Dixie core. often your Dixie core itself is compressed. So in most cases, you're not even really using Patina LZMA decompression because you would have had like PEI code or something else that would have had decompressor linked in and already decompressed most of your code. But there are cases where people do use LZMA, and we install decompress support. So we moved to this new crate LZMA Rust 2 to improve performance significantly, but also to move to a crate that's more maintained. And they also seem to be a little bit more focused on benchmarking and performance as well. So we think it's just a better fit for the project to use this for LZMA as opposed to the other one. All right. See if there's anything else here we need to that we haven't kind of already covered. Okay, I think that covers our recent work items in terms of like the major changes. The other thing we have going on as a long-term initiative, I won't go through all of these, is primarily the supervisor. And you'll see changes for that in the SUPV branch. So if you are interested in that work, you can again go to the branches here and go to SUPV. And this is where the supervisor code is being developed. Don't think there's any issues for us to talk about. There's been some stuff we've noted over the last month related to like maybe adding cargo fuzzing or cargo fuzz for fuzzing, and some other changes related largely to the supervisor and different things going on. But I think that covers most of the main work items there. On Patina QEMU, that's a repo where we have our QEMU code. We did add well, we've had nightly OS testing. What we've done in the past couple of weeks or so is, let's go to the history here. So this change will run the OS test on PRs. We were running like tests to boot to Windows and Ubuntu nightly in CI. And we realized that PRs are infrequent enough to this repo that we could run the OS test on PRs themselves, and it's not really that detrimental to overall PR time or anything or resources. So we did that here. There was we moved to QEMU 11 and needed to make a change for ARMvert to boot on that. So that change is made there. And then there was some work to consolidate some documents that were added to the repo, but not part of the MD book into the MD book. And so that was done there. I think I've mentioned this before, but we do have an MD book in this repo as well. You can click this link here, and that will take you to the MD book for the Patina QEMU repository. All right, that kind of covers all the things I had planned to discuss that's ongoing in the project and everything else. Does anyone have any discussions that they would like to have or any questions or anything like that? All right. If not, then thank you for joining, and I will talk to you in the next meeting. Bye.
Thanks.
Thank you. Bye.
Thank you.
Thanks.